Assalamualaikum and good afternoon. So we're going to start our discussion. Today I plan to cover topic 5.1 and 5.2. So first is going to be the introduction. 5.1 is going to be introduction of regression. And then topic 5.2, so we're going to start discussing on simple linear regression. So this is as usual. So I'm not going to explain to you everything in detail. So this is just a recap of every little bit of pieces that we have discussed in chapter 1 and also in 5.1 and also 5.2. So basically, what is the idea of simple linear regression? So basically, when we do simple linear regression, what are we doing is going to be these two ideas right here. So the first, what happened is that we are going to be given two variables. We call them variable x, the independent variable, and the variable y, so which is going to be the dependent variable. So first of all, what we're going to do is we wanted to know whether or not there exists a relationship between the variable x and y. So we wanted to establish the relationship. So if there is actually a relationship between them, so we can actually come up with a model out of them. If there is no relationship between them, then there is no reason for us to actually relate both of them. So we can simply drop the two variables. And as I mentioned just now, if the relationship actually exists, so what we can do is we can come up with a model. So what is the purpose of having the model? So what we want is that we're going to use the model for prediction. So the model is going to be in terms of x and y. So if we have the value of x, we can find the value of y. And if you have the value of y, we can find the value of x and so on. So it's going to be vice versa. So that is going to be the importance of the model. And there are going to be two models that we're going to discuss. So first is called as simple linear regression that we are about to discuss today. And another model is going to be multiple linear regression that we are supposed to discuss in 5.3. So now first let's have a look at simple linear regression. Okay, as I mentioned to you just now, so the fact that we have in our model, we're going to have two variables. Okay, the first one is called as the independent variable. So the independent variable in our calculation, so it is denoted as a function of x. So when you say about x, so that is actually representing the independent variable. So instead of being known as independent variable, so there are multiple names. It is also called as explanatory variable. So it's also called as predictor variable and also a regressor variable. So all of them actually is the same thing. So independent variable, explanatory variable, predictor, regressor. So they are all the independent variable, which is going to be x. And the other variable is called as dependent variable, or also known as the response variable. And it is denoted by the symbol that we use to represent dependent variable is going to be y. Okay, what is the difference between the independent and dependent variable? So independent variable is actually what we change on value. So when we do an experiment, so we change the value, so that is going to be the independent variable. And the dependent variable is the value as a result of changing the independent variable. So basically it's going to be the result. Why is it called as dependent variable? Because the value of the dependent variable so depend on the value of x. When x changes, automatically is going to change the value of y as well. So basically the idea is, I put over here, so y depend on x. Okay, so that is going to be the idea of the relationship between x and y. So y is going to depend on x. Okay, among the term that you should come across when you have a look at 5.1 is going to be correlation coefficient, or it's also known as Pearson product moment correlation, if I'm not mistaken. So there's another name for it. You can refer to it in your notes. So correlation coefficient is usually denoted by a symbol of small r. So small r, so that means correlation coefficient. So this, the name is called as correlation coefficient because this is actually a value that gives us the idea of the relationship between x and also y. So it measures the relationship. So how does it measure? Meaning that so if we want to know what is going to be the relationship between x and y, so it's going to give you a number that helps you to actually figure out so whether or not it is a strong relationship, whether it's going to be a weak relationship, whether or not there is a relationship at all. So it gives us the idea. Okay, the relationship, there are two types of relationship between x and y. So it could be a positive relationship. So positive relationship meaning that when the value of x increase, the value of y is also going to increase. So that is called as a positive relationship. And it could be a negative relationship between x and y, for which what happened is going to be the opposite. So when the value of x increase, the value of y is going to decrease. So that is known as a negative relationship. And how do we know whether it's going to be a positive or negative relationship? There are two ways. One, so you can sketch the scatter plot. So the scatter plot, and you have a look at the gradient. So whether or not they are actually positive or negative. And another way is by using the correlation coefficient value. So the correlation coefficient has a value, so that is between -1 and also 1. But the thing is that, so whenever you have a positive relationship, your correlation coefficient, the value is going to be between 0 and 1. So if you calculate R value, you get a value between 0 and 1. So it means that there is a positive relationship between X and also Y. But when you calculate, you get a negative value, so a value from -1 or 0. So that is called as a negative relationship. So it shouldn't be here. So 0 is not negative relationship, so not including 0. So if you get a value between 0, but not including 0 and -1, so that is a negative relationship between X and also Y. So we can tell this by using the value of R. Okay, and in terms of interpretation, so when the question asks us to interpret what does the correlation coefficient means? So you have to mention two things. So the first thing that you have to mention is going to be the strength. So based on the value, is it a weak relationship? Is it a moderate relationship? Is it a strong relationship? So the indicator is going to be in terms of the number. For example, so if you get a value between 0 until 0.5, or -0.5 until 0, so that is considered as a weak relationship. If you have a value between 0.5 to 0.7, so that is considered as being moderate. And if you have a value which is 0.7 until 1, so that is called as being a strong relationship between X and also Y. And you also have to mention the direction as well, whether that is a positive linear relationship or a negative linear relationship based on the value that you get from R. So if R give you a positive value, so it's going to be a positive relationship. If R give you a negative value, so it's going to be a negative relationship. So the idea is, for example, let's say if I calculated the value of R and I figure out that my R value is going to equal 0.35. So first of all, when I wanted to interpret this, I'm going to I have to identify the fact that, so this is a positive value. Okay, first of all, this is a positive value. So therefore, I know there's going to be a positive relationship between X and also Y. When X increase, Y is also going to increase. The second thing is that I have to realize is about the extent, the strength of the relationship between the X and the Y. So we have 0.35 over here. So this falls into the weak category. So therefore, what happened is that there is a weak relationship between X and Y. So the thing is that, why do we need to know the strength, whether it's going to be weak, moderate, or strong? If there is a weak relationship between X and Y, that is a relationship, but it's kind of weak. Our model is not going to be very good. It might be like dodgy. It might be like, if you use the model, then it's not going to be good for prediction. Okay, if that's the case of weak. If it's moderate, then sure, we can still use it. It's still usable, but it's not going to be very good for prediction as well. But if you have a strong relationship between X and Y, so what happens is that, so whatever that the model that you come up with is going to be a very good model. So X and Y, so you can use to predict, if you have the value of X, you can predict the value of Y and so on. Okay, they are going to be very useful for each other. So that will be the idea of correlation coefficient. So another term that you should come across after R, another term is going to be the R square. So R square has a different name. So R square is known as the coefficient of determination. Previously, R is known as correlation coefficient. R square is known as coefficient of determination. But of course, there is a relationship between R and also R square. So if you square this value, so you will get the coefficient of determination. So that is why the symbol is the same. This is R, this is R square. So when you square the value of the correlation coefficient, you will get coefficient of determination. Okay, so remember the value of R is going to be between -1 and 1. So if you square this value, you will get a value between 0 and 1. So therefore, R square value, it's expressed as percentage. So it's going to be in your calculation, it's going to be a value that I calculate between 0 and 1. Is it necessary if the question asks you to interpret, you express this in percentage? The answer is yes. Every single time we interpret coefficient of determination, it should be in terms of a percentage. For example, if let's say you calculate R squared and you get a value of 0.4, so we know that 0.4 is actually 40%. So you express that as being 40% instead of 0.4. Okay, and then after we have verified the relationship, so we are going to have a look at the model. If there is a very good relationship between x and y, so a model is going to be valid. But if there is a weak relationship between both of them, your model is going to be a bad one, so it's not useful. Okay, so this is called as a simple linear regression model. So I want you to be alert about this. That's called as not just simple regression model. No, it's called as simple linear regression model. So I'm pretty sure that you have seen this before, that you know the fact that linear means straight line. Okay, so this is what happens. So between x and y, what we're going to do is, so we're going to come across a model that actually uses the principle of a straight line. So what is an equation of a straight line? So this is what we learn in school. So the fact that when we have an equation of a straight line is given by y equal mx plus c. So this is actually the idea that we're going to implement for simple linear regression as well. But instead of using m, so the m stands for gradient, keturunan in Malay. Okay, so instead of using m, so we use a new notation which is called as beta 1. So beta 1 is called as the regression coefficient. And instead of using c, so we use beta naught. So beta naught is called as being the regression constant. So as mentioned to you just now, so what is m? M is actually the gradient, and what is c? C is actually going to be the y-intercept. Okay, so that is going to be the idea. So we actually use the idea of equation of a straight line to come up with a model, and our new model is known as y equal beta 1x plus beta naught. Okay, as I mentioned just now, m is the gradient. So how do we interpret gradient? What does it mean by the value of the gradient? Okay, for example, let's say if I were to sketch a function that looks like this, and this is going to be my straight line. So how do we calculate the gradient? So the gradient is denoted by m. So the gradient is actually given by the change in y over the change in x. So that will be the formula. So delta y over delta of x. So what does it mean by that? So it means that in our context, so gradient means that when x increase by 1 unit, how about y? Does it increase or decrease by how much? So that is what it means by gradient. For example, so let's say I have, this is going to be my gradient. I have m equal 2. So what does m equal 2 means? M equal 2 means that when my value of x increased by 1 unit, so it is specifically by 1 unit, so what happened to y? So y also increased by 2 units. So that is what it means by the value of the gradient. And it depends whether it's going to be increase or decrease. So it depends on our gradient. If it's a positive value, then yes, it's going to be a positive relationship. If it's a negative gradient, then it's going to be a negative relationship between x and also y. Right, so that is going to be the idea of our model. And how do you find the value of beta 1 and beta naught? So there is a specific formula in the book that you're going to use in order to find the value of beta 1 and also beta naught. So where are all the formulas? So this is going to be a statistical table. So this is actually on page number 8, simple linear regression on correlation. So this bit over here, so this is the formula on how to find R, the correlation coefficient. And in correlation coefficient, there are 3 important components that you have to find: SXY, SXX, and also SYY. And how do you find them? So there is going to be a specific formula for each of them. This is the formula for SXY, SXX, and also SYY. And even the model is given over here. And how do we calculate for beta 1 and beta naught? So it is also given in this table right here. So all you have to do is to know how to use it and how to refer for it. Okay, so I'm not going to show you, I'm not to explain everything in detail because I believe that you have already watched the videos on the YouTube, Stats YouTube for chapter 5. Okay, so now what I'm going to do is I'm going to start with the calculation for this particular problem right here. So this is actually a test 2 question. So previously we used to have test 1 and test 2, but we no longer have this. We only have 1 test for now. Previously this used to be assessed in test number 2. So this is from semester 1, 14-15. So it's a very simple question. So it says that a study is conducted to investigate the relationship between the boiling point of water. So basically this is our variable. So the first one is the boiling point of water and the barometric pressure, in barometric pressure, so this is going to be the unit. So the data is given in table 3. So we have this data over here. So we are being given the value of boiling point, and at this value of boiling point, so what is going to be the value of the barometric pressure? So first of all, so when you have a look at the question, you first have to identify, so what is going to be the x variable, what is going to be the y variable. So if you interchange them, x, you make it into y become x, automatically your whole calculation is going to be wrong. So the first step is you have to be able to identify, so which one is x and which one is going to be y. So can somebody tell me for this case right here, so when you have a look at this, which one is you think is going to be the x variable? So which one is the independent variable? Does boiling point depends on barometric pressure, or barometric pressure depends on boiling point?
I think barometric pressure is depend on the boiling point.
Barometric pressure depend on the boiling point. So actually it's the other way around. So what happened is that, so boiling point, so let me put over here SBP. So boiling point, so depends on the pressure, on barometric pressure. No, it's going to be the other way around here. It's actually the pressure, the barometric pressure. So it depends on the boiling point. So actually, when I read about this first, I have to actually go back and Google for what is barometric pressure, but I don't remember what is it anymore. Usually in the question, they are going to give you a hint of which one depend on which one. So for you to be able to figure out x and y. For this one, it is actually not clear which one depend on which one. But the point is that, so for this case, actually barometric pressure depend on the boiling point. So meaning that, so our independent variable, so is going to be the boiling point, and the dependent variable is going to be the barometric pressure. So we vary the boiling point, and as a result, the barometric pressure is going to vary as well. Okay, so now that the good news is that, so sometimes the question, it could simply just give you all this, and you have to find what is going to be this value, sum of x, sum of y, sum of xy, and how you find these values. So these values are actually found by using your calculator. So I believe that, I'm not sure, I haven't seen the video, but I believe that the video should have shown you on how to use your calculator to find all these values. But if they actually didn't show you how to do that, so get back to me. So I'll make a simple instruction for you on how to actually find this value by using your calculator. Okay, but the good news is that for this particular question, so it's already given. So you've been given that sum of x is going to equal this value. This is sum of y, sum of xy, sum of x squared, and sum of y squared. So as mentioned just now, so this is all fine by using the calculator. So the question asks you first to find the correlation coefficient. So correlation coefficient, as we have seen before, is actually the small r. And then we also have to interpret the value that we get. So this is the formula. So I copy it down. So I copy it from here. So I copy this whole thing right here and paste it right there. So that is going to be the formula that we are going to use, because according to the table, so this is going to be the formula for the R, correlation coefficient. So I need to find each of the component first, SXY, SXX, and also SYY. So which is given by this particular formula right there. So now I'm going to start my calculation. So I'm going to start with the first component, so which is going to be SXY. First, I come across a summation given by XIYI. So it's going to be this one. Okay, so I just copy down the value. So the value is going to be 31450.37. And according to the formula, it's going to be minus. And then I have sum of x. Sum of x is given by this value right here. So which is 1225.8. So multiplied by sum of y. So sum of y is going to be this one. So which is going to be 153.4 over the sample size. So and remember, n is going to be our sample size. So how do we know sample size for this case? Because it's not given what is going to be the value of n. So what you can do is you can simply calculate how many samples taken. So there's going to be sample number 1, number 2, number 3, number 4, 5, and 6. So therefore for this case, so we have 6 samples altogether. So therefore we are going to divide this by 6. Can someone calculate for me what is going to be that value for SXY?
110.75.
Okay, 110.75, is that right?
I think so.
No,
Yes.
no, is that
Yes,
what you
I
get
would
from your
assume.
calculator?
Yes,
Ah,
miss.
okay, okay.
Okay.
I'm not confident.
So now that I already have s of xy, I'm going to find s of xx. So it's going to be pretty much the same idea. So I come across, previously we used sum of x, but now it's going to be sum of x squared. So which is going to be represented by this right there. So I'm going to have a value of 250,609.96. And according to the formula, so that is going to be minus, and sum of x, so that will be 1225.8, but then it has to be square. So I'm going to square that and again over the sample size, so which is going to be 6. So calculate that for me first. And I'm going to proceed to the third element, so which is going to be the SYY. So according to the formula, first I need what is going to be the sum of y squared, so which is right there. It's given by 3995.34, so minus sum of y, so that will be given by 153.4, and that is supposed to be square and divide by the sample size, so which is going to be 6. So has somebody calculated what is going to be the value of the SXX?
179.
1790.
1702.
Okay, 179.02. What about SYY?
74.41.
74.41. Is that right?
Yes, miss.
Okay.
73.4.
73.
73.4.
So is it exactly like 2 decimal places? So remember that we're supposed to do our calculation with 4 decimal places. So this is exactly 73.41. There's no more numbers at the back.
73.413.
3, only 3.
3 again.
Okay, so it's 73.4133. Thank you. Okay, so now that I have all these elements, so then only I can apply the formula to find R. So this is going to be the formula. So let me copy this. So I'm going to paste it right here. Okay, so now all I have to do is substitute all the values that I have obtained. So S of xy is going to be given by 100 of 10.75. So divide by, so I'm going to have a square root. So that contains a product between 179.04. So multiplied by 73.4133. And this product, both of them are going to be square rooted. So that we can do our calculation. And if you use your calculator, you should be able to figure out, so that this is going to be a value of 9661. So that is going to be our value of R. So remember, in our calculation, so everything has to be in 4 decimal places, or I can actually deduct your marks for that. All right. So the reason why we actually standardize to 4 decimal places, because it helps us lecturers to mark your paper. If this person is using 2, this person is using 3, this person is using 4, I end up having to do all your calculation all over again just to make sure that your value is actually correct. So that is why we wanted to make it standardized, so everyone has to calculate by using 4 decimal places. But for this too, why is it in terms of 2 decimal places? Because that's what the calculator give you. So it's actually 110.7500 or 179.0200. So that is why we only use 2 decimal places. But if a calculator give you 4 or more, so you have to take at least 4 decimal places. Okay, so now that we already have the value of R, so we got R equals 0.9661. So can somebody tell me, so when we wanted to do our interpretation, I did mention just now, so we have to mention 2 things. So first is going to be the direction, and the other one is going to be the strength. So what is going to be the strength of this number, 0.6991? So is it going to be considered as being weak, moderate, or strong? If I have 0.9661.
Weak.
Strong.
Okay.
Strong, miss.
Strong, that's right. So if you have a value, let's refer back to what I've written just now. So if we have a value which is between 0.7 until 1, or negative 0.7 until negative 1, so that is considered as a strong relationship between x and also y. So therefore, for this case, So we are going to have a strong relationship. So that is going to be the strength, the direction, because this is a positive value of R. So therefore, automatically, it's going to be a positive relationship between X and also Y. So when I write my interpretation, I have to mention both of this. So the strength and also the direction. So I can say that. So that is a strong, positive, or you can also write positive, strong, doesn't mind. So which one comes first, it doesn't matter. There is a strong positive relationship, positive linear relationship. So this is compulsory as well. So you have to mention the strength, the direction, and the fact that it's linear, because here we are talking about linear relationship. We're not talking about other type of relationship, because relationship between two variable, it could be anything. It could be a quadratic relationship. It could be an exponential relationship. But for this particular model, so we are focusing on linear relationship. So you have to mention the linear. Strong positive linear relationship between. So now you have to mention, so what is your variable X and also Y? So my variable X is given by the boiling point. So I'm going to say between the boiling point and the barometric pressure. Okay, so that is going to be the interpretation. So how many marks are given for this? 9 marks. So calculating each of this is going to be 2 marks, 2 marks, 2 marks, 2 marks. That is already 8. And and interpreting the interpretation, that is going to be another 1 mark. So just by calculating this, so you will get 9 marks already. Okay, that is going to be for the value of R. So next question. So it says, write the fitted line equation of the simple linear regression model. So basically, so what the question is asking you is for the model. So we're going to come out with a model, and then we're going to estimate the pressure. So when the boiling point is 10 degrees Fahrenheit. So now let's first what do you call that? Let's first calculate what is going to be the model. So in our model, as I mentioned to you before, the model is going to be given by this. So you can have y equal beta 1x plus beta naught. So that is going to be our equation. So that is actually y equal mx plus c. So m is being replaced by beta 1, c is being replaced by beta naught. And of course, so each of the component, beta 1 and beta naught, so that is going to be a different formula for them. So let's copy this formula. Okay, so that is going to be the formula. So now I'm going to start my calculation with finding the beta 1. So beta 1 is given by sxy, so whichever we have already find in our previous calculation. So that is given by 110.75 over sxx, which is given by 179.02. So what is my value of beta 1? What value do you get out of that?
.6186.
Okay, it's going to be 0.6186. So that is going to be my value of beta 1. And then next, I'm going to find the value of beta naught. So beta naught is given by this formula. So it's given by y bar minus beta 1 of x bar. Can somebody tell me? So what is y bar and x bar? What does it mean by having a bar at the top?
Not Y, not X.
Not?
Not Y, not X. I don't know.
No, it's not. Not why not. I get what you mean. So that is set notation. So if I have A, so it's going to be not A means that it's going to be yeah, that is set notation, but that's not going to be the same goes for a set notation. You've come across this before. What is the symbol for X bar? So what does X
Mean?
bar stands for? Exactly.
Does it mean?
So, yeah, that's right. It's mean. So when you have Y bar, so this is actually mean of Y. So mean of y. So x bar actually stands of mean of x. Okay, so that is what I meant by the y bar and also x bar. So in this calculation, of course, so we are being given the data. So we can put this into your calculator and find what is going to be the mean. Okay, however, there's no need to do so here, because we know that how do we calculate for mean? For example, if I wanted to calculate the mean of x, all I have to do is I'm going to sum all the values of x. For example, let's say if I have 1, 2, 2, 3, and 4. So I'm going to add them up. 1 plus 2 plus 3 plus 4. So that is basically the sum of x. Sum means that add up everything. And I'm going to divide by the number. So here I have 1, 2, 3, 4. So I'm going to divide by the sample size. So that is how do we calculate mean. So that is going to be the same idea for y as well. So therefore, what I'm going to do is, so how do I find the mean of y? So the sum of y is already given in the question. So this is the sum of y. So it's given by 153.4. So I'm just going to substitute. I'm going to have 153.4. So divide by my sample size. So according to what we have seen before, so there are sample size together. So that is going to be our y bar. So minus, so beta 1 is going to be given by 0.6186. So multiplied by x bar. So it's going to be the same idea. So sum of x has already been given in the question. It's given by a value of 1225.8. So here I'm going to have 1225.8. So divide by 6. So that is going to be our value of beta naught. So what's beta naught value?
Negative 100.8133.
Okay, negative 100.8133. So that is going to be the value of beta naught. So now that we already have all those values, so all we have to do is substitute back into our model. So according to the values that we get, our model y is going to be given by beta 1, so which is given by 0.6186x plus beta naught, so plus negative. Of course, it's going to be negative. So I'm going to have minus 100.8133. So this is going to be our model. So basically, so this model is ready for prediction. If I have the value of y, I can find the value of x and vice versa. If I have the value of x, I can find the value of y. So this is what we're going to do next. So we are going to use this model for prediction. So the question said over here, so estimate the pressure when the boiling point is 10 degrees Fahrenheit. Why is it in Fahrenheit? I think that the symbol, I think this question is wrong. Okay, if you notice right here, so it's been written that the boiling point is given in degree of Celsius. It doesn't matter. It doesn't make sense 10 degrees Fahrenheit. So this is actually wrong. So this actually should be in terms of 10 degrees Celsius. Okay. So this is not physics. We're not trying to make you to what you call that, change the unit and so on. There's no such thing as stats. Whatever that we give you, you use that value. Okay, so now what happened here is that we're going to estimate the pressure. So remember, the pressure is going to be y. So when the value of boiling point, so which is x, is equal 10 degrees Celsius. So that is how we're going to use our equation. So we're going to find y is equal 0.6186. So when x, the value is actually 10. So I'm going to substitute 10 over here. So minus 100.8133. And when I calculate this, so I will get a value of negative 94.6273 in terms of the pressure. So this is going to be our value. So all we have to do is substitute value of x, and then automatically we will get what is going to be the value of y for that particular x value by using our model. So that is what we are expected to do. Okay, so that's it. So that is all that you have to do for this question. So that is a total of 7 and 9, 16, 17. So just by doing all this calculation, so you will get 17 marks. But as I mentioned to you just now, so the thing that I want you to be very careful is how to determine the value of x and also y. So you have to read the question very carefully, because once you got them wrong, interchange, automatically your whole calculation is going to be wrong. So we try to avoid that. I think I don't want to do this one. I'll leave it to you to do this question right here. I think I want to do this question because they are more like, what do you call that? Conceptual problem that we can discuss together. Just have a look at this question. So this is a final exam question from semester 116-17. So the question said that a stall owner in Teluk Cempedak, Kelantan, so wishes to a relationship between, so this is going to be our variable. So the first variable is going to be the highest daily temperature, so which is in degrees Celsius, and the second variable is going to be the number of 500 milliliter mineral water bottles sold for a particular day. So it's going to be in terms of y. So here, So the question already tell you, so which one is going to be x and which one is going to be y. So basically our x variable is going to be the highest daily temperature, and the variable y is going to be, so based on that, what is going to be the number of mineral water bottles sold on that day. So he records the highest daily temperature and number of 500 milliliter mineral water bottles sold at his stall for 15 consecutive days. So how many samples are there? So basically we have 15 sample taken from 15 consecutive days. So the scatter diagram for the recorded data is given in figure 1. So from whatever data that this person gets, so he come out with a scatter plot. As I mentioned to you just now, so there are two ways of finding the relationship between x and y. One is going to be from the value of r, so we can see the correlation coefficient in terms of the direction and the strength. And second is by sketching a scatter plot. So this is how the scatter plot looks like. So here this is going to be our x variable and this is going to be our y variable. So the first question, it says, based on figure 1, so answer the following question. So which variable is measured in interval level? So we have two variables, number of bottles and temperature and highest daily temperature. So which variable is called as being interval level?
Temperature.
That's right. So the interval level will be the temperature variable. So remember we discussed this in chapter 1. So we have level of measurements, is it ordinal? Yeah. So nominal, ordinal, interval ratio. So interval, so temperature is categorized under the interval level according to the level of measurements. So it says identify the response variable. So response variable is going to be the y variable. So it is actually another name for dependent variable. And for this case, it's going to be the number of bottles sold. Okay, so that is going to be our y variable. So the question says, so identify the pattern of the data from the scatter diagram. So comment on the relationship between the variable. Okay, first of all, so let's have a look at the scatter plot. So what is the pattern that you can observe from the scatter plot itself? So when you have a look at this, what do you have in mind between the relationship between x and y?
Increasing.
Increasing? What is increasing?
Um, the value of y and x.
Okay, so meaning that, so when the value of x increase, the value of y increase as well? Is that what you mean?
Yes.
Yeah, okay, so so that is going to be one thing that you should notice. Okay, the thing is that what can you actually conclude from the scatter plot itself? So there is a positive relationship. So if I were to give this a diagram, so if I were to make a line out of this, so my line is going to look like this. So basically, there is a positive relationship between x and also y. So that is one thing that we can see over here. So the question says identify the pattern. So what can I say about the pattern is, hold on. So there is a positive relationship between x and also y. So positive relationship between temperature and number of bottles sold. Okay, so that is going to be the pattern. So we have a positive gradient. So the question said again, so comment on the relationship between the variables. So as your friend Ami mentioned just now, so what happened is that, what does it mean by the positive relationship? So when the temperature increase, so that is our x value. So when the x value increase, so the number of bottles sold also increase. So that is what we can comment about the relationship. Okay, so first, positive relationship. Second, so the fact that when x increase, y also increase. So that is going to be the comment. So by just saying those two, so you will obtain 2 marks. And then the next question says, in your opinion, so will the slope for the line of best fit be positive, negative, or 0? So the slope, the gradient, when you sketch a linear graph, so it could either be positive, positive mean going up, or it could either be negative, so which is going down, and it could also be 0. So what does a gradient of 0 actually means? So when you have a positive gradient, so it means that when x increase, y is also going to increase. So it's the other way around. So when you have a negative gradient, x increase, y is going to decrease. So when you have a gradient of 0, so this is actually a gradient of equals 0. It doesn't go up, it doesn't go down. So meaning that whatever value of x is, it's not going to change the value of y. Or in other words, no relationship between x and also y. So that is what I mean by having a gradient of equal 0. But you have seen just now what I've done to describe right here. So if I were to put a gradient, a line across all these scatter plot dots, so we will able to figure out that that is going to be a positive slope going on. So it's going to be a positive. Okay. Right, so for B, the recorded data of the highest daily temperature. So it's going to be pretty much the same idea as before. So just now we started at what time? So we still have another 18 minutes. So this is pretty much going to be the same calculation as before. So I'm not going to calculate this. I will leave it that to you. But I'm going to discuss with you the other stuff. But here, the coefficient of determination. What is coefficient of determination? Anyone remember what symbol does we use for coefficient of determination just now?
R squared.
Exactly. So the coefficient of determination is given by r squared. So how do we find r squared? So we found r squared from r, and r is actually given by the correlation coefficient. So how do we calculate correlation coefficient? So by using this formula that we have done just now. So basically, so the calculation for this is going to be exactly the same as what I have done in the previous question. First, you're going to find r, and then from finding r, you're going to find what is going to be the value of r squared. So I think I have the solution somewhere. Let me find this first. Where's the solution for this? Okay, from your calculation, so you will find that. So please do your calculation on your own. Please try the calculation. Okay, so r is going to equal, you should be able to get r is going to equal 0.8612. But the question doesn't want r, so the question actually asks you for r squared. So all you have to do is you're going to square this value, so which is going to be 0.8612 square, and that's going to give you a value of 0.7417. So that is going to be our coefficient of determination. And the question also asks you to interpret the result. So how do we interpret the result? As I mentioned to you in our previous discussion at the beginning, so when we wanted to interpret for coefficient of determination, it has to be, it has to be expressed in terms of a percentage. So 0.7417 is actually 74.17%. So that is a standard way of interpreting coefficient of determination. So how to interpret? So the interpretation is going to be like this. So percentage, so you're going to mention the percentage of the variation in y can be explained by x. So that is how we interpret the coefficient of determination. So this is a standard way of interpretation. All you have to do is, so you're going to find the percentage and substitute what is your y variable and what is going to be your x variable. So for this case, so I'm going to write that 74.1% of the variation in y. So what is my y variable? And the number of bottles, that is my y variable. So can be explained by the x variable, which is the highest temperature of the day, by the highest temperature of the day. Okay, so that is going to be the interpretation. So it is standard. All you have to do is substitute the percentage. So substitute the y variable and substitute the x variable. That's it. So that is going to be your interpretation of r squared. Okay, and question number 2 over here. So the question asks you to use t-test. I'm not going to discuss this today. So this is going to be our topic of discussion for the next online class, because what happened is that this is going to be in topic 5.3. So this will got to do something with the ANOVA table. So I'm not going to discuss this today. And that is a lot of marks. So that is going to be 11 marks. And it is a very popular final exam question. So we will discuss this next week. And question number 3. So it says find the predicted regression equation for the data. So as I have shown to you in the previous question as well. So when you want to find the predicted regression equation, so you need to have all the elements in the model. So you need to find, so y is going to be given by beta 1x plus beta naught. So basically what you have to do is you have to find what is going to be the beta 1 and what is going to be the beta naught. So in terms of the calculation, it's going to be exactly the same as I have shown to you earlier. So therefore, I'm not going to do this. I'm not going to repeat the same calculation. So I'm simply going to give you the answer. So we can proceed to the next question. So try this calculation on your own. So you will be able to get that. The model is going to be given by negative 88.6709 plus 4.5497x. Okay, so that is actually the other way. It doesn't matter. So you can also write this as beta naught plus beta 1x. They are actually the same, just the order is different. Okay, so that is going to be my model. So the question number 4, it says that based on your answer in 3, so this is going to be related. So interpret the regression coefficient. Can somebody tell me? So what is regression coefficient? What is regression coefficient? What is the symbol of regression coefficient?
I'm gonna guess, but I think it's R.
R is correlation coefficient, Ame.
Oh, sorry, to R square. R.
R square coefficient of determination. Now it's regression coefficient.
Beta.
Which beta? We have two beta, beta 1 and beta 2. So which one is regression coefficient? Okay, let's refer back to what we have discussed earlier. Okay, so regression constant, there are two regression parameter. So one is known as regression constant. So one is known as the regression coefficient. So which one is the regression coefficient? So beta 1 is the regression coefficient. And what is beta 1? Remember y equal mx plus c. So the one attached to the x, so that is going to be our gradient. And for this case, our beta 1 regression coefficient, so it's going to be the gradient value. So let me scroll back to where we are just now. So which is here. Okay, so now what is our beta 1? So from our calculation, so beta 1 is going to equal this value. So which is 4.5497. So the question asks us to interpret. So what does this value mean? 4.5497. As I mentioned to you before, so what is actually gradient? So gradient is actually the changes in y when x increased by 1 unit. So that is what we're going to explain over here. So we're going to tell, so what does this number mean? So when x increased by 1 unit, and what is our x? X for this case is going to be temperature. So when temperature increased by 1 unit, so which is going to be 1 degree Celsius for this case, so the number of bottles sold will also increase by 4.5497. So every 1 degree Celsius increase in temperature, so the number of bottles sold is also going to increase by 4.5497. But of course, in terms of this is not going to be a very good interpretation. So we should say that it's going to be approximately 5. It's increased by approximately 5 bottles, because we know that bottles cannot be in terms of decimal places. Okay, so basically that is going to be the idea. So what does the figure of beta 1 actually mean? So it's going to be a gradient value. So when x increase by 1 unit, so this is our gradient. So when x increase by 1 unit, so how much does the value of y increase or decrease? So if your beta 1 value is negative, for example, let's say if I have beta 1 value is equal negative 5.3, so it means that when x increased by 1 unit, so y decreased by 5.3 units. But this one, because it is a positive value, so that is why when x increase, so y is going to increase as well. But if you get a negative value, so when x increase, y is going to decrease. So that is how you interpret the beta 1. Okay, so next, for this particular question, so we have, if there is a significant linear relationship between the variable, so estimate the highest daily temperature if 45 bottles of 500 mineral water were sold. So now I want you to try to use this model. So this is going to be our model. So if the highest daily temperature, so the question asks us to estimate the highest daily temperature. So that is going to be our x. The question asks us to estimate x if, so y is actually equal 45. So please calculate, substitute into this model right here. So tell me what is going to be the value of x when y is equal 45. So when you substitute, it's going to look like this. 45 is going to equal negative 88.6709 plus 4.5497x. So now, so what is going to be the value of x for this case?
29.3802.
Okay, so you got 29.3802. So this is temperature. What is the unit? So it's going to be in terms of degrees Celsius. So that is going to be the value of x. So we predicted using our model. So we can predict if 45 bottle is being sold that day. So it means that the highest temperature on that day is 29.3802 degrees Celsius. So that is what we're calculating over here. And for the next question, it says if a 500 mineral water bottle is being sold at 120, so meaning that one bottle, the cost is 120. So predict the sale. So when the highest daily temperature is 40 degrees Celsius. So now we are being given that x is equal 40. So what is going to be the value of y? So what's the value of y? So when x is equal 40. Y is equal? What value do you get? All you have to do is substitute over here equal 40. And you will get the value of y.
93.3171.
Okay, you get 93.3171. Okay, because again, this is number of bottle. So I'm going to round it up. I'm going to say that, so if x is equal 40, so the number of bottles sold will be 94 bottle. Okay, now the question doesn't ask you how many bottle, but the question asks you predict the sale. So how much that you get from the sale that day if one bottle costs you 120. So therefore, what I have to do is I have to multiply. So 94 multiplied by 1 ringgit 20 cent. So the sale from the 94 bottles, so that is going to be 112 ringgit and 80 cent. So that will be the outcome. Okay, so be careful. So read the question very carefully. What is it asking for? Okay, the last one. So it says over here, a stall owner in Penang. So the sample over here, where is it taken? So this particular sample is taken by a stall owner in Teluk Cempedak, Kuantan. So it's taken here. But now it says that stall owner in Penang also wishes to use the same predicted regression equation. So the owner wants to use the same model to predict his daily sale of 500 milliliter mineral water bottle. So does his predicted sale reliable? So mean that, what does it mean by does his predicted sale reliable? So can the owner use the same model that we use for this particular problem? Yes or no? What do you think? Is it possible that the owner in Penang also want to use our model? Would it be a good model for his stall?
Logically, it's no. It's depend on his like the other things.
Okay, that's right. So if Rami said no, okay, the answer is no. So why is it no? So the easiest answer for this is when you do model for simple linear regression, there is limitation. Okay, what the first limitation is that in terms of the numbers. For example, let's see over here. Let's see our data. Where's our data? Temperature. Oh, we don't have temperature. Okay, so the temperature over here. So our temperature goes from the lowest is 28 and the highest is going to be almost 40. For example, let's say I want to use this model to predict when the temperature is going to be negative 2 degrees Celsius. For example, I want to use this particular model for a stall that is in South Korea. So is it possible? No. The answer is no, because so your model, when you do for prediction, so the value has to be in the same range. So if the temperature is between 28 and 38, so you have to use it only for figures that is between this range of value. So you cannot use this to predict X values that is outside from this sample. You cannot predict it for a temperature of negative 2 degrees Celsius. You cannot predict this for temperature that is 60 degrees Celsius because our maximum is about 40 degrees. So that is going to be the first limitation for simple linear regression. So the second limitation, so which is what happened for this particular problem, for the particular question just now. So for a sample that is taken in Pahang, so we cannot, what do you call it? We cannot also imply it somewhere else. Okay, so we wanted to use it in Penang. The answer is no, because when we have different population, so customer behavior will be different as well. So we cannot assume that whatever that happens in Kuantan is going to be the same as whatever that happened in Penang. The simplest example is that, so let's say we do a survey in Malaysia and we come out that, okay, 70% people in Malaysia actually enjoys eating nasi lemak. So we couldn't actually implement that if we were to take this to Saudi Arabia, that 70% of people in Saudi Arabia is also going to enjoy nasi lemak. No, it's not going to be that way. Okay, so whatever that happened, sample that is taken in Pahang can only be used in Pahang. So the model cannot be implemented somewhere else. So which is Penang for this case. So that is the answer for our question right here. So does his predicted sales reliable? No. Because why? Because we have a different population. So I want you to remember the limitation very well. So it doesn't mean that when you have a model, so everyone can use the model. So it doesn't mean that way. We have a different population because everything depends on the population that we have. If we have similar population, yes, probably it's applicable. Okay, but when our population is completely different, then our model is going to be unreliable. It's going to be a bad model for you to use for prediction. Okay, so I actually, as I mentioned to you just now, so I actually skipped one question in the middle. So I expect you to try this on your own, but this is a scatter plot. I already sketched it. I'm just going to leave it there so you can use that later. So this is actually for question number 2. Okay, so try this problem. So this is also from final exam question. Let me warn you the fact that chapter 5 is going to be, I think, about 30 marks or 20 plus marks for the final exam is going to come from chapter 5. So that is a lot of mark. So you better know chapter 5 very well. Okay, so before we leave, is there anything that you would like to ask regarding what we discussed today or regarding anything about our lesson?
No, doctor.
Okay, so if you don't have any questions, so we're going to stop here for today. Don't forget you have a quiz on this coming Thursday. So it's just going to be on 1 way and over. That's it. So I've written in detail about the hours it's open and such on the WhatsApp group. So I'll see you guys on the next class next week then. So we'll discuss 5.3. Right, I'll see you guys then. Bye.
Thank you very much, doctor.
No problem.
Thank you, madam.
All right.
Thank you, Miss.
No problem.